Now in this problem we have two astronauts who are orbiting Earth in the same circular path, 180 degrees apart from each other. And astronaut A has two sandwiches while astronaut B has none. So we're asked to find a way for astronaut A to throw a sandwich to astronaut B. And we're also asked to find the time it would take for that to occur and the length of the semi-major axis of the orbital path of the sandwich. Now, there are many possible solutions that you can come up with, but in this video we will only be discussing two of these possible solutions. So, our first possible solution is to throw the sandwich from point A into an elliptical orbit with half the period of the astronaut's orbit. So this means that when the sandwich completes one complete orbit and returns to point A, astronaut B will have traveled half the orbit of this ellipse and be at the same location as point A, which means that astronaut B will be able to grab the sandwich after half a period has elapsed. So the time it will take, which we'll call T prime, in the first method is just going to be half the period of the astronaut's orbit, which we'll call T. So that's going to be T over 2. Now the length of the semi-major axis of the orbit of the sandwich we will call R prime. That's going to be determined by Kepler's third law, which states that the square of the period of the orbit is proportional to the cube of the semi-major axis. So written in terms of R and T, we have the period squared is proportional to the cube. So that means that semi-major axis is proportional to T to the 2/3, which means if we divide T by 2, or if it travels in half the period, then the new semi-major axis will be equal to the semi-major axis of the astronauts divided by 2 to the 2/3, which is equal to R over 4 to the 1/3, which is approximately 0.63 R. So that's the length of the semi-major axis of the orbit of the sandwich. Now, another way we could get a sandwich to person B, or astronaut B, is for person A, or astronaut A, to throw a sandwich in the opposite direction with equal velocity, so that the sandwich will travel in the same elliptical orbit as the astronauts, but just in the opposite direction. So in this case, the semi-major axis of the sandwich's orbit is just the same as the astronaut's semi-major axis, R. And the time it will take, by symmetry of the path, astronaut B will meet up with the sandwich after it has traveled a quarter of its path of its orbit, which means that the time it will take is just the period divided by 4, which is a lot shorter than our method in the first part. Now, there are many other possible solutions, and I encourage you to try to find more of them.